All right, so 2-6. Talk about ratios. Okay, so a ratio by definition is a comparison of two numbers using division. Okay, so the ratio of two numbers A and B, where B cannot be 0. So we're using division. So whatever you divide by cannot be 0. That's all it's saying. We're going to have 3 different ways to write ratios. And my hopes are that you recall this stuff from previous years. One way to write a ratio using A and B is to write A to B like that. Have you guys been exposed to that? Like A colon B? Okay, it means the same thing. We even read it A to B. Okay, but the most useful method for mathematics is to write it as A over B or A divided by B, because that then allows us to kind of do our operations. Okay, but all of those say the same thing, and they're going to ask you in homework to display your answers in those various formats, but they mean the exact same thing. Bless you. Understand that A to B does not equal B compared to A. Does that make sense? If I ask you how many times does 2 go into 4, 2, that's different than how many times 4 goes into 2, right? Half. Okay? So, comparison-wise, the order is important. Okay? So that's how we identify what ratios. If you guys remember when we talked about the grouping of numbers, we had natural numbers, whole numbers, integers, and the next list was rational numbers. Okay, well, the key word for rational was ratio, right? That was the or the root word. And because in any rational number, we're doing A divided by B. Okay, where A and B are just integers. So I want to kind of use this next example. It says, suppose the ratio of the number of boys to girls in a class is 2 to 1. I want to use this in several different kind of problems here. It says the ratio can be expressed the following ways. Using what we just talked about, we can write a ratio as 2 to 1. We can write it as 2 colon 1. And we can write it as 2 over 1. Okay? But remember, each one of those is boy to girl. Okay? Boys being the first number, girls being the second number. Does that make sense? And that's important to know that order of comparison, because if I tell you you have 12 boys, you should be able to tell me how many girls you have. If it's a 2 to 1 ratio, you have 12 boys, how many girls do we have? If you have 12 boys in the class and there's a 2 to 1 ratio, for every 2 boys, there's 1 girl. That's what that's saying. Okay? So if I have 12 boys, how many girls are there? 6 girls, right? Okay? When they tell me a ratio like this, okay, most of the time that ratio is reduced. Okay? Meaning if we were looking at this class, let's say that we have, and this is not accurate, but let's say we had 12 boys in here and 6 girls in here. Okay? We would reduce that if we're talking to somebody about the ratio of boys to girls in here. We would not say it's 12 to 6. We would reduce it to 2 to 1. Does that make sense? Now, 12 to 6 would tell me we have 18 people. Does that make sense? 2 to 1 tells me I'm only looking at 3 people. Does that make sense? But it means in that group of 3, for every 3 of them, there's only 2 boys and there's only 1 girl. Okay? So that idea helps me answer questions like the one we just said. If I've got a 2 to 1 ratio where this is boys and this is girls, if I have, 13 boys, let's say we have 13 girls, how many boys are you going to have? Careful, because it's going to be reduced down to 2 to 1. You have 26. Okay? Does that make sense, everybody? Huh? So what that means is, okay, so instead of using 26 and 13, let's go, I just want to use smaller numbers. Let's say I have 5 girls, I have 10 boys, right? Okay. So the idea is, if it's a 2 to 1, if I have 5 girls, so let's say there's 1 girl, there's 2 girls, there's 3 girls, there's 4 girls, there's 5 girls, right? Those are my 5 girls. Okay. Then for this 2 to 1 ratio says for every one of these, you get 2 boys in that group. Okay. So then for that girl, there are 2 boys in this group. For that girl, there's 2 boys in this group. For that one, there's 2 boys. And then for that one again, we've got 2 boys. How many boys do you have here? You have 10 here. You have 5 there. If I look at 10 to 5, does that reduce to 2 over 1? So that's the idea. For every 2 boys, you get 1 girl. For every 1 girl, you get 2 boys. Okay? So now, let's do this. If ratio of boys to girls is 2 to 1, okay? Now, when I say that, this is a word, if you might have seen this written before, they might say, Mr. Fay and Travis are 35 and 15 years old, respectively. 14, okay? Because I use that word respectively, does anybody know what that means?
Ideally.
Huh? Let me write the phrase down here.
Wait, what?
So let's say Mr. Fay and Travis are 35 and 14 years old, respectively. Okay?
Does that mean like they are, or like?
Well, here's my question. Because I said 2 names first, right?
Yeah.
And then I said 2 numbers, right? 2 ages.
Yeah.
How do you know that, Mr. Fay? Now, you would know this because you know me and you know Travis. How would you know that if you knew nothing about the 2 of us? How would you know which one's 35, which one's 14?
Because your name has missed first.
Okay, so my name came first. So then I pair that with the number that came first.
Oh.
Travis's name came second, so we pair his name with the number that came second. Now we only do that because we use the word respectively. Does that make sense? Okay. Whenever you see that, you'll see that in your English test, you'll see that in the ACT, you'll see that on the end of the course again. I'll use that word respectively. It just means in the order that the things were stated, kind of link those to the order that the characteristics of those objects were stated. Okay? That's what the word respectively means. So if a ratio of boys to girls is 2 to 1, now, when we say the ratio of boys to girls, I lay that out, because I said ratio, it kind of takes the place of the word respectively. So you know boys links to what number? 2, and girls links to 1. Okay. Now, let's ask this question. If there are 42 people in class, how many boys? Okay? Now, some people might say, I'm going to do a guess and check. I'm going to do a guess and check and say, okay, well, if there's 42, there's got to be 2 and 1. Maybe I draw that picture that we did when it was 10 and 5. Then we do something like that, and that's fine. But then I'm going to say, well, what if you have 142 people? Do you want to do that? Or if I say, well, you have 1,042 people? You don't want to have to do that, right? Okay? So there should be a way that we can use this ratio to help us. Okay? Now, remember, that ratio, 2 to 1, is boys to girls, right? This is saying people. I want to know how many boys. Okay? So how many boys, if I look at this 2 to 1, I look at that group, there are 3 people in that group. Does that make sense? So when I say 2 to 1 in regards to boys and girls, I am also telling you it's 2 to 3 if I compare boys to people. Does that make sense? I'm telling you it's 1 to 3 if I go girls compared to people. Okay? Or girls to total, or boys to total. So when I want to compare this, or use this ratio to tell me how many boys are out of the 42 people, I will say 2 boys for every 3 people should equal how many boys out of 42 people. Does that make sense? Okay? So it's the same logic as what we were doing when I said it was 2 to 1, and then I said I had 10 boys, how many girls should I have? Or if it was 2 to 1, I had 5 girls, how many boys should I have? It's the same idea, but now, instead of talking about boys and girls, I'm talking about boys compared to people, boys compared to totals. Okay, so now the B and the P here, those are, just to remind me what those numbers are representing. The equation I'd really have here would be 2/3 is equal to x over 42, right? Okay. Did we work on some equations like this previously, where we had fractions? Okay, you can, I don't want to do that right now. I don't want to cross multiply right now because that's not properly what we've talked about. Maybe you've been informed on that in other classes. I just want to multiply this by the LCD. If I multiply that by 42, multiply that by 42, does this 42 cancel there? Now 42 is 14 times 3. Does that 3 cancel with that 3? Does that make sense? So I have 14 times 2, which is 28, and I have x on the right-hand side. So what did I solve for here? I solved for how many boys are out of this 42. I have 28 boys out of 42. How many girls would you have if you had 28 boys? How many girls would you have if you need 42 people? How many? Wouldn't you need 14 girls? Does that make sense? Now here's my question. All I did is I took 42 minus 28, right? I guess you have 14. What is the relationship between that number there and that number there? If I take 28 and divide it by 14, what does that reduce to? 2 to 1, doesn't it? Is that the ratio that we started off with boys to girls? Okay. So that type of problem, guys, is where we're going to get to in some of this work with ratios and proportions that this section and a couple of the other sections are going to target. Okay? Understand that if I say boys to girls, it's 2 to 1. If I wanted to flip that and say girls to boys, it would be 1 to 2, right? So we need to understand that those are different statements. Okay. That brings us to a unique type of ratio, a special type of ratio. It's called a rate. Okay? And you guys are familiar with rates. But it's a comparison of quantities that are measured in different units. Okay? For instance, I'll just draw a comparison to what is not a rate first. So if I had like 10 centimeters divided by 20 centimeters, those centimeters cancel each other out. Okay, we do the same math that we do with numbers with units. So that just gives me 10 over 20, which is 1 over 2. That's a ratio, right? No units. Okay? However, if I ever get to something where maybe I have, maybe I work a job and I make $4.25 for every 2 hours. Okay, how can I cancel out dollars and hours? No, the only reason I could cancel centimeters and centimeters is because they were both distances, right? They're both the same type of distance in that case as well. If it was feet and centimeters, we could do a little work to actually get those to cancel out as well. But if it's dollars and hours, they are different things. They're not. You can't convert dollars into an hour. You cannot take time and convert it into money, right? Okay, so that is then left with those units, and we have dollars per hour. Okay? So this is read as the word per, right? So if I were to divide this out, I get, what, $2.12.5. Okay, so that would be $2.125 per 1 hour, right? Does that make sense? Okay, so that is what we refer to as a rate. Now, I put it in the wrong.
Are you kidding?
That should be right there. I apologize.
I even wrote it in pen.
Well, then just circle it and then put an arrow. So that's what a rate is, okay? You've seen miles/hour, and that slash, that division symbol with the units stands for the word per, okay? Division means, or is analogous to the word per. So miles per hour, right? I can't take a distance and change it into a time. I can't take a time and change it into a distance, so it has to stay with those units. Gallons per hour. Okay, GPH, if you ever had to fill a swimming pool or drain a swimming pool or something like that, gallons per hour would be something you'd be interested in. Okay, miles per gallon, if you guys are getting ready to drive, right? Okay, so maybe interested in buying cars. Maybe you want to get one that has a high miles per gallon so you save money in gas, right? Okay, so understanding that stuff and what it means to us might allow us to make decisions that affect us. Okay, a unit rate. Another special rate, okay, another special ratio. This is actually a special type of rate, okay? But it's a rate in which the denominator is 1. The quantity on the bottom is 1, okay? So when they give you your hourly rate in your job, they're not going to say, you're going to make $16 for every 2 hours. They're going to say you're going to make $8 for every 1 hour. Does that make sense? Okay, so because the denominator had a 1, that's called a unit rate. Unit, whenever you see the word unit in mathematics, it refers to 1. Okay, anytime you see the word unit, it refers to 1. If you go to the store and you're going to, Myers does this, Walmart does this, I think Chiefs does this, on the racks, when you look at the price tag of something, it will give you the price of the item. Okay, so you got to buy last class we were talking about Tide Pods. So we'll go buy a bag of Tide Pods. It'll say one bag of 36 Tide Pods is, $7.45. Okay? So one bag is $7.45. But then it's going to go down even further and say, but every Tide Pod, okay, if I take $7.54 or whatever I said, 45 cents, and divide it by 36, it will tell me a unit price, how much I'm actually paying for every individual Tide Pod. Does that make sense? Okay? So you'll see that allows people to make decisions, because here's the idea. I'm going to be doing laundry for the rest of my life, right? Does that make sense? So does it make sense for me now to spend $7.45 on 36 Tide Pods, or does it make more sense to spend $30 on 144 Tide Pods? Because at some point, I'm going to use 144 Tide Pods, no matter what, because I got to do laundry, right? So in the long run, is it more lucrative financially to me to buy in bulk than it is to buy in a smaller amount like 36? Okay? So those are things that are on the shelves at Walmart that you can look at and to make decisions. Okay? Sam's Club's the same way. Okay? So those are unit rates. Those are probably the places you've seen unit rates used the most. All right? Conversion factors. Conversion factors. So sometimes we like to go between, I want to change gallons into quarts, or liters into milliliters, or, cubic centimeters into gallons, or feet into miles, that kind of stuff, right? Okay? So we need what we call conversion factors to do that. Okay? Conversion factor are two equivalent measures, but using different units. So this says the units will be different, the quantities will be different, the numbers we actually use will be different. But if I were to take those physical things, if I take 128 liquid ounces, okay, and set it next to a gallon, they're both the same amount of volume. Does that make sense? If I take 12 inches and lay them out on my desk, and then I put a foot right next to it. Do they measure the same length? Yes. Okay. Different quantities, different numbers, 1 and 12, or 1 and 128, but they still represent the same object, the same amount of something. Okay. So common conversion factors, you know, 1 foot for every 12 inches, right? Okay. Sometimes you'll see it written 1 foot equals 12 inches, something like that. Either one of these is fine. What about, we'll just write a couple here. Do you know how far 1 mile is in feet? Good, 5,280. Okay. Anybody know how many yards are in a mile? 1,760. Okay. So 1 mile is 1,760. And the reason for that is how many feet are there in a yard?
13.
1 yard, 3 feet. Good. Okay. So if I take 3 feet times 1,760, it should give me 5,280. Does that make sense? So those are some common, maybe distance conversion factors we know. There's one that allows us to talk about a new system. Okay, so when we talk about inches, miles, feet, yards, that's called the English system, sometimes called the imperial system. And we are one of 3 countries in the world that use that. Okay? Everybody else uses the metric system or the SI system, right? Which has meters and centimeters and kilometers and all that kind of stuff, right? Okay? If somebody gives me a measurement in feet or miles or yards, and I want to convert it into kilometers or meters or centimeters, that relationship right there is what I would use. If I go to a ruler and I look at 1 inch and I draw a line to the other side of my ruler, it's going to pass through 2.54 centimeters. Does that make sense? Okay. How many yards are in a foot? No. How many yards are in a foot? 1/3 of a yard is inside a foot. You said how many yards are in a foot? If you say how many feet are in a yard, there's 3 that make up a yard. But if you reverse it, it's a third of one of these will make up a foot. And this is actually a meter stick. But, so up to there, up to that hand, 3 feet will make up that yard, right?
That's how long it is in the football field?
No, between each marker, yeah.
It does not feel like that.
It
You
is.
tell me that every step I take on football field, I'm basically going 3 feet.
Yeah.
So I'll be like jumping like 6 feet, dude. So it goes like, I go like 2, 3 dashes when I run. It's like 9. He goes like 2.
All right. So the metrics. So this is the thing that students in America have issues with, is because if I ask you what it feels like to go 55 miles per hour, you know what that feels like, right?
No.
Yeah. You sat in a car that's going 55 miles per hour. If I ask you what's it feel like to go 72 kilometers per hour, you probably don't know how that feels, right? Maybe it makes sense to change that 20 or 72 kilometers per hour into miles per hour, so you have an idea of how fast that really is. Because you've probably experienced 72 kilometers per hour, but you've defined it as miles per hour, so it would be a lesser number. Okay, so we have the need to be able to jump back and forth between these two systems. Okay, anybody ever been to Canada?
No.
Okay, so in Canada, when you're driving down the road, because Canadians, there's a large English-speaking population and there's a large French-speaking population. So they, on their road signs, everything is written in English and then it's also written in French. So on a road sign, it might say 45 miles per hour, but then underneath it, it says whatever that is in kilometers per hour. Okay. Well, in order to do that, we would need to have the ability to be able to jump between these two systems. Okay. So 1 inch to every 2.54 centimeters gets me to be able to jump from the imperial system to the metric system. Okay.
You never answered that question.
Well, you asked how many yards were in a foot. That's 1/3.
1/3.
Yeah, but I don't think you phrased the question the way you really wanted to answer or ask it.
Look, like on the back, how many yards? 63 yards.
You're doing those wrong. Don't worry about those.
No, I'm asking how many yards are in a foot.
1/3.
1/3.
Oh my God.
Yeah, so every
So you're asking a question, I'm giving you the answer, and then you're refuting that question or answer.
3 yards.
Do you know it's 1 foot?
No.
Oh
For-
my Lord.
For every 3 yards, it's 1/9 of a foot. All right, we'll get to those. We'll explain that. For every 3 yards, there's 9 feet, right? Because every 1 yard, there's 3 feet. We'll get there. Don't worry. That's the one concern that I have when I write these notes up, guys, is that we don't pay a whole lot of attention to what we're doing right now. We just try to get through those problems. Don't do that, okay? Now, these are common factors. I'm going to print out a paper for you, hopefully by tomorrow, that has a whole lot more on it. That'll let you use on tests and quizzes, because I think there's a lot we should know. We should know 1 foot 12 inches. We should know 1 foot or 1 mile, 5,280 feet. Those are common knowledge things. But there are also some things that maybe you don't know. How many pints are in a quart and how many quarts are in a gallon, that kind of stuff. Now, some of those names are important. Quart means quarter. Quarter refers to a fourth. So a quarter, how many quarts are in a gallon? 4 quarts in a gallon, right? And then we got pints and all your cups and all that kind of stuff. So we'll talk about that stuff. Okay. I believe it's 2 pints in a quart. And then was it 2 pints or 2 cups in a pint, something like that. And then those are things that if you're not using that system enough, that stuff you would probably be using like baking, right? Anybody in here great bakers or bake all the time? Okay. Then maybe you know that stuff, okay? But if you're not working with that every day, you probably forget that knowledge. So I will write out a paper for you that when you're working on your homework, tests, and quizzes, you can use that. And of course, exam gives you one. That's probably the one that I'll give you. Unit analysis. This is kind of all targeting. Is the process of conducting algebra with units to recognize after a series of operations, and multiplication, division is going to be those operations, what unit is left over for my solution. Okay. So an example of that. A couple examples here. It says the CN Tower in Toronto, Canada. Okay, is about 1,815 feet tall. I want to know how tall is that in meters. How do I convert that? Okay. We're going to use this fact that 1 meter is equal to 3.28 feet. Okay. Now that's a bad estimation. Okay. And your textbooks are going to do this. Your homework's going to do this. In the story problem, they will give you a conversion factor. If they don't, we'll use the conversion factor that I give you on the sheet that I print out tomorrow. You guys remember, like in 5th grade, 6th grade, when they asked you to use pi? What did you use for pi? 3.14, or maybe you use 22/7 as a fraction, right?
Or you can click the pi button.
Okay, but if I click the pi button, I'm going to get a different answer than the person that gets 3.14, right?
Well, yeah, I know. You can click the pi button and you click that if they tell you.
Okay. So when we use 3.14, we're using an approximation for the actual pi value, right? If I use 3.28 feet here for 1 meter, that's actually an approximation for a meter. Okay? It's not the best. If I use 1 inch equals 2.54 centimeters, that will give me a much more accurate, more precise answer. Okay? And we'll talk about that if we have time. All right, but here's the plan. Here's how we do this. First thing you're going to write down is the amount that you start with. So we're starting with something that is 1,815 feet tall, right? Everything that you start with, if it is not a fraction, you turn it into a fraction. You put it over 1. Okay? Now, what I think is the best thing to do is give yourself a little bit of room. And here we're going to need 1. We're going to multiply by 1 fraction, so it's not a whole lot of room we need here. But when I do these problems in general, we might need to multiply by 3 things or 4 things or 5 things, and we don't really know that right off the bat. So I like to give myself a little bit of room, and I come over here to the end, and I decide what do I want my answer to be in. What do they want my answer to be in? Meters. So I'm going to write that unit down. I know I'm starting with feet, and I need to get to meters. Okay? Now, bear with me here. If I asked you to take 2/3 and multiply it by 3/5, could you write that this way?
Yeah.
What are you going to recognize about those threes? They're the same, so what do they give me? Okay, they give me 1, and then I'm left with the 2/5, right? So most people, though, when they do this multiplication, they're just going to cancel and cancel, right? Okay? We can do the same thing with units. We do the same exact algebra with units. So what I want to do here is I start with feet, but I need to get to meters. So does it make sense that feet needs to cancel out? Okay, so I'm going to put feet right there. Does that make sense? Because then there's one in it. There's a unit of feet in the numerator. There's a unit of feet in the denominator. They will cancel out, much like that 3 and 3 canceled out on the bottom. Okay. Now, once I do that, you can go through and you can slash those out if you want to. But now we're going to ask the question: is there a direct link now from feet to get me into the answer that I want? I want meters, right? Is there a conversion factor that it links meters and feet together? Yeah. What is that conversion factor?
1 meter is 3.2.
Okay, so I'm going to write M right there. Okay, I'm not going to put my numbers in yet because the unit analysis says your numbers don't matter if your units are wrong. Does that make sense? Okay, so let's make sure we get those correct first. If we get those correct first, then it's really easy actually to get the right numbers. Okay? So if I were to multiply everything out, even if I didn't cancel, and kind of using this idea down here, I'd have 1815 feet times meters times 1 times feet. Well, don't those two things cancel out? Does that make sense? So that's the logic of why we could cancel them here and here. Okay? When I do multiplication with units, I do that multiplication just like I would with numbers. Okay. Once we have that down, we know we're going to be left only with meters right now, and that's where our answer was supposed to be in. Now we go and plug in the values that should be here. So you said 1 meter, so I put 1 there, and 3.28 feet should go there, right? Now when I multiply straight, because it's fraction times a fraction, multiply straight across the top, get 1815. Multiply straight across the bottom, I get 3.28. And when I do that division, correct me if I'm wrong, is it 5.3 or 3.5? 1815 divided by 3.28, 3.5 is what I thought. And that's in meters. Okay? My hope is that some of us start to say, well, why I got to do that work? I know I'm going to take 1815 divided by 3.28, and so give me my meters. Okay? I know some of you thought that. Okay? And that's fine. Okay? But my next question, and we have time to do this, so my next question is, what would this be if I gave you the fact that 1 inch is equal to 2.54 centimeters, and I asked you to go from 1815 feet to meters? Okay? Not knowing that previous conversion factor that we used. Okay? So let's go through the same process. I put this over 1, right? Okay? Now, I need to put feet there because they need to cancel, correct? Okay, so if those cancel, the question then is, do I have a conversion factor that gets me from feet to meters? And we don't, right? Our conversion factor that I'm supplying you with right here is 1 inch to 2.54 centimeters. So what I need to do is I need to think about how can I get what I'm in right now. I'm in feet right now. Is there a link between either of the units that are in that conversion factor? Does feet relate to centimeters at all, or does feet relate to inches at all? Is there a link between any of those? Do feet and inches relate to each other, guys? Okay, so I'll put inches here. Because there's a relationship that we know, a common conversion that we know between inches and feet. So I multiply everything out, my unit would be inches. Well, I want meters. Well, let's do this. If inches is there, I need inches here so that they cancel out, right? Is there a link between inches and meters? There's not, right? But is there a link between inches and centimeters? Okay, so I'll put centimeters right here. Okay? Now, I want to get to meters. Does anybody know a link between centimeters and meters? Huh? What does centi mean? How many cents are in a dollar? How many cents are in percent? 100. Yes, centi means 100. Okay? So, look at this unit analysis. That inch cancels with that inch, this foot with that foot, centimeter with centimeter, and all I'm left with is meters, right? So let's go put numbers in now. How many inches and how many feet? It's usually best to let the bigger thing be 1. So feet are bigger than an inch, right? How many inches are in a foot? 12. 12 inches for every 1 foot, right? How many centimeters for every 1 inch? How many centimeters for every 1 inch? 2.54. How many centimeters for every 1 meter? 100. Okay. So now let's multiply. 1815 times 12 times 2.54. All over 1 times 1 times 1 times 100. If I multiply that out, so 1815 times 12 times 2.54 divided by 100. You see the number I get there? Okay. Earlier we had 1815 divided by 3.28, right? Are those numbers pretty close to one another? Okay, but the 553.212, I think in the notes I actually wrote it 533, but 553.212, that's a better answer because 2.54 centimeters equals 1 inch is a better conversion factor. There's a homework assignment, but it's not due tomorrow. See ya.